Hi, now we will understand about wind load calculations for rectangular buildings. Now, this is the equation for wind load calculation, where F is the wind force, Cp and Cpi are external pressure coefficients and internal pressure coefficients. A is the tributary area and Pd is the design wind pressure. Now, this is the top view of wind flow. Now, wind is coming from the left side. Here wind is coming from this side, and these 2 points are the wind separation point. In these 2 points, wind is actually detaching from the building surface. And here you can see in this particular zone, the wind velocity is quite high. And as per Bernoulli's principle, we know that in a particular zone, if wind velocity is quite high, it is obvious that there will be significant drop in wind pressure. So there will be suction in this particular zone just after the separation point. And here you can see for these two side face there will be some sidewash of wind, and if there is sidewash of wind also, that also will create huge amount of suction. So this particular two side face will experience significant amount of suction. So this is the front face. Here we will experience that there is significant amount of positive pressure that will push a particular face. And for this two face, due to this flow separation and sidewash of wind, here actually there will be significant amount of suction. And in the leeward side also, as there is vortex formation here, here also there will be significant amount of suction. Now this is the side view. Here also you can see that in this particular separation point, flow separation is occurring. And again, for the top surface of the building model, here also there will be significant amount of suction due to this particular vortex formation and flow separation. Now this is the table of external pressure coefficient. External pressure coefficient depends on two parameters. One is the building height ratio, which is the h by w, and building plan ratio, which is l by w. Now, what is h, what is l, and what is w? H is the height of the building model, but over the ground surface. So, under the ground, that value we will not consider. We will not consider the value up to the foundation. We will just consider the value which is over the ground surface. And what is L and W? L is the longer dimension of the building model, and W is the shorter dimension. So L is longer, and when wind is directly hitting the longer dimension, at that time we will consider the wind angle as 0 degree. And when wind is directly hitting the shorter dimension, we will consider that particular wind angle as 90 degree. Now, for different cases of H by W and L by W ratio, the values of external pressure coefficients for different phases are given in this particular table. And here also another important thing is also there, that is local CP. Let us take an example. Suppose there is a particular building model for which the H by W ratio is in between 3 by 2 to 6, and L by W ratio is in between 1 and 3 by 2. Now for this particular building, if wind is hitting the longer side, what we have already said, that when wind will hit the longer side of the building model, at that time we will say that wind angle is 0 degree. Now for this case, here you can see that for phase A is the windward phase. Here Cp value is 0.8. So positive 0.8 means it is actually the pressure which is acting over this particular surface. And for phase B, which is the leeward side, here the value is minus 0.25. That means this is suction over this particular surface. And for the side face C and D, the Cp value is minus 0.8. And another thing, it is also very important, if we are doing the detailed design, at that time the local Cp value we have to also consider. Local Cp value is minus 1.2, and local Cp value is applicable just after the separation point. This particular 25% of the side face, here we have to provide the local Cp value. Local Cp value is highly important for doing the cladding design just near the separation point. Now, in place of 0 degree wind angle, if wind comes from 90 degree wind angle, suppose wind is coming from 90 degree wind angle, here this phase A, here the Cp value will be minus 0.8. Minus means suction. For B phase, it is again minus 0.8. For C phase, it is plus 0.8. That means here actually there is pressure. And for D phase, it is minus 0.25. So again there is suction. Now one thing we have to remember that actually these two face are side face now. For previous condition, for 0 degree wind angle, C and D are the symmetric phase. When wind is coming from 0 degree, at that time C and D both are symmetric phase and their CP value was same, minus 0.8. But when wind is coming from this particular direction 90 degree, at that time A and B, these two phases are symmetric phase and their CP value will be similar, here minus 0.8. And again just after the separation point, these two separation point, here in this particular zone 25% zone, here we can consider the local pressure coefficient for doing the cladding design, and local pressure coefficient for this particular zone is minus 1.2. Internal pressure coefficient CPI depends on the opening percentage area. Like for a particular building model, if the opening percentage is less than 5% of the wall area, at that time we will consider the value of CPI as plus minus 0.2. If the opening area percentage is in between 5 to 20%, at that time we will consider the CPI value as plus minus 0.5. And if opening percentage is greater than 20%, at that time we will consider the CPI value as plus minus 0.7. Now why plus and why minus? If for a particular building model it may happen that wind is behaving in such a way that it is hitting a particular face. At that time, if there is push over that particular surface, at that time the value will be positive. But for a particular condition, if there is suction over a particular surface, then it will be negative. Both will not occur simultaneously, but both can happen if there is huge amount of opening for a particular building model. Now this is an example. If opening percentage is in between 5 to 20%, at that time CPI will be plus minus 0.5. Now what is plus 0.5? Plus 0.5 means the wind is actually hitting all the building surfaces. And what is minus 0.5? Minus 0.5 is suction over all the building surfaces. Now this is our previous building model, for which this is phase A, B, C and D. For phase A, the CP value is plus 0.8. For B, the CP value is minus 0.25. Here for phase C and D, the CP value is minus 0.8. And this is the CPI value plus 0.5. Now while doing the design of wind force, we know that we have to calculate the value of CPE minus CPI. So what will be the CPE minus CPI for the front face? It will be plus 0.8 minus 0.5. So plus 0.8 minus 0.5, it will be 0.3. And it is quite obvious because here plus 0.8 is acting in the right direction and CPI is acting towards the left. So both are actually counteracting each other. So this value is decreasing when we are calculating CPE minus CPI. For the side face, actually this thing is different, because side face CPI and CPE both are acting in the same direction. So it will be minus 0.8 minus 0.5. So both are behaving in same direction. So the value will increase and it will be minus 1.3, which is actually suction. And in the leeward side also, here you can see that CPE is minus 0.25 and CPI is 0.5. So both are acting in the same direction. So the value will be minus 0.75. Now again, when we are considering the CPI value as minus 0.5, so when CPI will be minus 0.5 for the windward phase, the CPE minus CPI value will be 0.8 minus minus 0.5. So there is 2 minus, so it will actually increase the value and it will become 1.3. Again the logic is same. CPE and CPI both are acting on same direction. Same direction means towards the right. So both this particular value are actually adding with each other. So it is 1.3. Now for the side face, now you can see that CPE and CPI are acting on the opposite direction. So one will actually balance the other by certain amount. So minus 0.8 minus minus 0.5. So now CPE minus CPI will become minus 0.3. And for this particular phase, minus 0.25 minus minus 0.5. So it will become 0.25. Now when the value is positive, it is actually pushing this particular phase. So again for the leeward phase, here actually there is positive value, that means it is pushing the phase. But here For these two phase, the value is negative, so it is suction in nature. Now let us take an example of a particular building frame, and if we consider this particular node, then we can calculate that how much wind force is coming over this particular node. Now the value will be Cp minus Cpi into A into Pd. Similarly, just opposite point of the node in the same building model, here also there will be wind force, which will be Cp minus Cpi into A into Pd. Now in the windward phase, the value of Cp minus Cpi, Cp suppose 0.8 and Cpi is 0.5, then Cp minus Cpi will be 0.3 into A into Pd. So 0.3 is the positive value, which is actually pressure over this particular nodal point. Similarly, in the leeward side, the Cp value is minus 0.25 and Cpi value is 0.5. So minus 0.25 minus 0.5, it will be minus 0.75, and minus 0.75 means it is actually suction over this particular nodal point. So total force is minus 0.75 into A into Pd. A is the tributary area. As mentioned in the previous video also, what is tributary area? Tributary area means that wind load of how much area is actually affecting a particular node. Now if we consider this particular node, then what is the influence area or tributary area? Along this particular left side of beam or right side of beam, we have to consider half and half. So half portion of this beam and half portion of this beam will come under the influence of this particular node. And again for the column also, half portion at the top and half portion of the bottom, this area, considering this particular area, this area will be the influence area of this particular node. So this is the influence area. We already calculated the value of Pd. So when we will know the influence area and Pd, we will get the total wind force over this particular node. And also on the opposite side, we will get what is the total wind force over this particular node. So similarly, for every node in a particular building model, by calculating the value of Cp minus Cpi, then multiplying it with the total tributary area and design wind pressure, we can calculate the total wind force over a particular building node. Thank you.